Hello everyone, welcome to the playlist of High Voltage Engineering. In this session, I will be discussing about the basic terminologies which are going to use in high voltage testing. There are different procedures for conducting high voltage testing. So before moving on to the procedure, you should know what are the basic definitions or basic terminologies that will really help you out to understand the testing procedure effectively. Let us have discussion individually. As you know that these are the different terminologies which will be using for HV testing. Disruptive discharge voltage, flashover voltage, puncture, withstand voltage, 50% flashover voltage, 100% flashover voltage, creepage distance, AC test voltage, impulse voltage, and finally reference atmospheric condition. Let us familiar individually. What do we mean by disruptive discharge voltage? Now let's familiar what do we mean by disruptive discharge voltage. The voltage which produces the loss of dielectric strength of given insulation material or dielectric material. That means, technically speaking, collapse of voltage, sudden drop of voltage and conduction will be taken place. That means passage of current. That is a result of applying disruptive discharge voltage. That means permanent losses will be taken place solid dielectric material, where temporary loss will be occurs in case of liquid and gaseous dielectric material. That's a peculiarity. Because of applying disruptive discharge voltage, dielectric loss will be taken place. That results the dielectric breakdown. Okay, that is a word meaning disruptive discharge voltage. Now let us understand what do we mean by flashover. Flashover is nothing but the dielectric breakdown that will be taken place in case of liquid and gaseous dielectric material. These dielectric breakdown are temporary. It can be recovered. That means when a discharge taking place in between two electrodes in a gaseous or liquid dielectric material is known as flashover. Consider two electrodes. In between two electrodes, you are going to keep either gaseous or liquid dielectric material. Thereafter, you are going to apply high voltage. Once the peak value has been reached, definitely what is going to happen? Dielectric breakdown will be taken place. That particular voltage that is known as flashover voltage. Okay. In case of liquid dielectric material and gaseous dielectric material, it will be flashover. But in case of solid dielectric material, we must say that the puncture will be taken place. Puncture is associated with a solid dielectric material. It is a permanent. That means when a discharge occurs through solid insulation medium is generally known as puncture. For solid dielectric material, the main phenomenon which will be taking place is puncture, where in case of gaseous and liquid dielectric material, that is belong to flashover voltage. So these are the important terminologies. Let us move on. I would like to explain what do we mean by withstand voltage. As the word suggests, the voltage which has to be applied to a test object under specified condition in a withstand test is known as withstand voltage. Alright. As per Indian Standard 731 and Indian Standard 2099 to 1963, so we can define the withstand voltage in this manner. What do we mean by 50% flashover voltage? I already introduced what is a flashover or what is a flashover voltage. The flashover is applicable for liquid and gaseous dielectric material. This is the voltage which has a probability of 50% flashover when applied to a test object that results the loss of insulation trunk temporary. Why? Because this is applicable for liquid and gaseous dielectric material. So you have to underline the word probability of occurrence of flashover is 50%. That is why it is known as 50% flashover voltage. Okay, the voltage whenever you are going to apply, there is a probability of occurrence of flashover around 50%. That is why it is known as 50% flashover voltage. So this is applicable for liquid and gaseous dielectric material. When I talk about 100% flashover voltage, the voltage that causes a flashover at each of its application under specified condition when applied to test object as specified is 100% flashover voltage. There is a probability of occurrence of flashover voltage is 100% over a test object. Okay, then we can call this is a 100% flashover voltage. This is also applicable for liquid and gaseous dielectric material. I'll be moving on to next presentation, the next slide. What do you mean by creepage distance? Consider two electrode. you are maintaining two electrode and in between you are maintaining a dielectric material. The distance between that two electrode is generally known as creepage distance. It is the minimum distance or shortest distance between two metal fittings or two electrodes on the insulators or dielectrics are generally known as creepage distance. Okay. What do you mean by AC test voltage? Alternating test voltage, or you can call AC test voltage, should have a power frequency in the range of 40 to 60 Hz. That you have to note down. The range of power frequency is 40 to 60 Hz. And the shape will be sinusoidal. That is another peculiarity. Then if I talk about the tolerance, the deviation allowed for the sinusoidal wave is 7%. It may be plus 7 or minus 7%. The deviation can be checked by using peak value, then average value and RMS value continuously. So this is the standard definition of AC test voltage. That is also required. So you have to note down about the frequency range. You have to note down about the frequency range, the shape, the deviation. Then you are going to check the deviation by using peak value, average value and RMS value continuously. I would like to explain what do you mean by impulse voltage. I already explained in the second module what is an impulse voltage. So impulse voltage are characterized by polarity. That is one of the most important property. Then peak value, then wave front and wave tail and time to half the peak value of after the peak. These are the things which are related to impulse voltage. Okay. So you need to know how to measure wave front, wave tail, peak value, etc. The time to front is defined as 1.5 times to the time between 30% and 90% of peak value in the rising portion of the waveform. That is related to wave front. What do you mean by reference atmospheric condition? The electrical characteristics of the insulators and other apparatus are normally referred as to the reference atmospheric condition. Okay, just like a standard condition. According to the IS specification or Indian standard specification, we can define the standard temperature, that is defined as 27 degrees Celsius. Then pressure can be noted down as 1013 millibars, or you can write in terms of torr also. Okay, both are unit of pressure, 760 torr. And regarding absolute humidity, it is in terms of 17 gram per meter cube, or else different standards also available apart from Indian standard specification. Let us go through different type of standards such as British standard. So regarding the British standard specification, temperature can be defined as 20 degrees Celsius, then pressure equal to 1013 millibars or 760 torr. Then regarding the absolute humidity, it will be 11 gram per meter cube. Okay, so 65% relative humidity will be considered at 20 degrees Celsius. Now let us calculate the flashover voltage. How to calculate the flashover voltage of the test object? This equation is very important. Let me show the equation first. You can familiar. So that means the flashover voltage Vs can be calculated by using the formula Va into H by D. What do you mean by Va, H and D? Let us familiar. So Va is known as voltage under actual test conditions. Similarly, Vs is known as voltage under reference atmospheric condition. That means flashover voltage. H is the humidity correction factor. Then D is the air density correction factor. There is a formula for calculation of H and D separately. Let me show you how to calculate humidity correction factor and air density correction factor. So you can calculate the air density correction factor by using the formula D is equal to 0.289B divided by 273 plus T for 20 degrees Celsius. If I talk about other standard, normal IS standard, this is for British standard, and if I talk about IS standard, you can calculate the air density correction factor D is equal to 0.296B divided by 273 plus T. This is for 27 degrees Celsius. That means IS standard. The first one is for British standard, where B is known as atmospheric pressure in millibars and T is the atmospheric temperature in terms of degrees Celsius. So I have referred those textbooks to gather those definitions and further information. So in this session we are familiar the various testing terminology that will be really helpful to understand the exact testing procedure for high voltage insulation testing. Thank you very much for watching this video. If you found this channel useful, please do subscribe. Thank you very much for your continuous support.